Subtracting polynomials is very similar to adding polynomials. We just need to remember that we need to take every term over in this polynomial away from every term in this polynomial. In this case, we have a trinomial and we want to subtract another trinomial. The difference between subtraction and addition is with the subtraction sign. I need to make sure that I distribute that to each of the terms in the second polynomial in order to subtract. The first polynomial just gets rewritten 4r to the fifth minus 6r squared plus 12r. I will distribute this minus sign to ensure that I subtract all of the terms in the second trinomial. Taking away or distributing a negative to 3r squared would give me negative 3r squared. Distributing the subtraction or the negative to the negative 2r to the fifth minus a negative, or a negative times a negative, becomes a positive 2r to the fifth. And finally, that subtraction sign also gets distributed to the positive 7r, making that become a minus 7r. Working from left to right, combine your like terms. 4r to the fifth gets combined with 2r to the fifth to make a total of 6r to the fifth. Negative 6r squared will combine with negative 3r squared. Negative 6r squared minus 3r squared is negative 9r squared. 12r will get combined with negative 7r because they are like terms. 12r take away 7r gives us positive 5r. Remember, before we move to the next problem, we want to ensure that this one is in descending order. The powers on the variable go from 5 to 2 to 1, so they are going down in value. Question number 12 works the same way. We want to take this binomial and subtract that polynomial. We need to make sure that the 4 terms of this polynomial get subtracted from the 2 terms of this binomial. To do that, we need to make sure that we distribute the subtraction sign. We do nothing to the term in front but write it down, 5x to the 4th minus 2x squared, and distribute the subtraction sign. So when I distribute the subtraction sign to a positive 3x, it becomes a negative 3x. When I distribute that subtraction sign to the negative 2x squared, it now becomes a positive 2x squared. When I distribute the subtraction sign to the negative 4x cubed, it becomes a positive 4x cubed. And finally, distributing the subtraction sign to the 6x to the 4th gives me a negative 6x to the 4th. Working from left to right, we combine our like terms. 5x to the 4th can be combined with negative 6x to the 4th to make negative 1x to the 4th. Negative 2x squared can get combined with positive 2x squared. Negative 2x squared and positive 2x squared actually cancel each other out. Negative 3x. There are no like terms to combine with negative 3x because this has a power of 3 and this doesn't. So we simply write it down. And then our last term is 4x to the 3rd, and there are no like terms to combine with that. So we just write it down. Our last step is to make sure our problem is in descending order. I notice that the power goes from 4 down to 1 and then back up to 3. That is not descending order. The largest power on our variable is here, so the negative x to the 4th will come first. The next highest power that we see is this with the x cubed, so that 4x cubed term will come second. And then finally, the minus 3x term will come last. We are now going from 4 down to 3 down to 1. You try number 13 and 14.